to make it that difficult for you.
Wait, 2.5 for real though?
No. 0,2. That's the y-intercept. What else do I need besides the y-intercept?
You need the slope.
Right.
Oh,
So if you're in standard form, Corel, you can do the x and y-intercepts. But if I'm looking here, I have a y-intercept, I'm going to look for that slope. So the next clean point is right here, right? I don't see any other points on intersections except for these. Now I can figure out my slope. I'm going
down to the right.
so down how much?
I don't know how much that is correct. 1, 2, 3.
Down 3.
Yeah, over 1.
Don't say over.
To the right 1.
To the right, because to the right is
Positive.
Alright. So notice my slope, rise divided by run, is -3. So I had to write the equation of the boundary line. Y equals -3x plus 2. I'm so close, but I have an equation, not an inequality. Sir?
Where'd you get the 2? Oh, yeah.
Okay? So after I can write the equation, all I need to do is change the equal sign to an inequality. How do I figure out what the inequality should be?
Well, there's 2 ways to do this. A, you could check the points, or B, you could just kind of look at it and be like, it's less than or equal to y, because the shaded portion is to the left of the axis, the intercept. Sorry.
Let's work on that language. That's good. Does anyone know what part of what Peyton said I would want to push on?
It's on quadrant 1 and 2 instead of 3 and 4.
Hold on 1 second. Alright, so here's my boundary line right here. Tell me again, which direction should I be shading?
Left.
No.
Negative.
Down.
Left. Oh.
Remember, it's a y value that we're talking about, right? So we're talking about shading up or down. And so we don't do left or right, we go up or down because it's a y, right? Y is up and down.
It
So
doesn't matter, I mean, it's all a solution.
it does matter because, nope, not that. So here it is. Notice how I'm shading down right now? But that would be to the right. So it depends on the slope.
The lines make a difference.
Well, if you were to say that it's shading to the right, would to the right be greater than or less than?
Still equal to the same thing.
That would be a greater than idea. To the right is a greater than idea. And if you have it as y equals mx plus b, you don't want a greater than or equal to. Does that make sense? Okay? So it's about greater than up or less than down. Okay? And then Peyton, you originally said it shouldn't be or equal to. Do you still stand by that?
That's just because the line.
What about the line?
I mean, it's just solid.
So if it's a solid line, it should be or equal to. Remember, when it's dashed, it's strict, and it's less than or just greater than. Does that help everybody understand this a little bit better?
I'm not confused. I thought it was a dash one.
Right. But like, again, this is why we have some review. I know that like it's a pain in the butt to do homework, but you got to have the review so that you can have those, oh yeah, that's right, I do remember this now. Any questions before we move on? Going once. Going twice. So you may hold on for just a second. You good? Alright, so here's the next set of problems. We're only going to focus on April 14th and 15th, part 2, because that'll help you with this week. So number 2, which point lies in the solution set for the system? And then we're given a system. What's the most important word in that question? Which point lies in the solution set for the system?
Solution.
Point.
Point does matter, but say it again, Peyton.
Solution.
Why does solution matter the most?
Because you could be finding anything. You could be on the y-axis, you could be finding the x-axis, you could be finding the intercept. Because there is an intercept, you could be finding anything.
You could be finding so many things, right? So what do we mean by solution, though?
What makes both of them true?
Both of what?
Inequalities.
Okay.
The system. What makes the system true?
Okay, now you're focusing on that idea of system for a second, but just the word solution, ignore system, ignore inequality, ignore equation, just in general, that one word solution, what does it mean?
It means set of, it means the set of things that make that true.
That, so a value or values that make the equation or inequality truthful, right? Right? Those are big picture ideas, right? I pointed out two major things for that previous question. Here, it is super critical to understand that a solution makes the equation or inequality true. And then because it's a system, it has to make how many of the inequalities true? Both. Right? So how did I determine that B, 3, 1 was the correct solution for the system?
Because you made both equations. Or systems true?
Made both systems true?
Yes.
Let's work on that language.
What's the wrong, like, what did I say?
Well, if you say both systems, how many systems are there?
Two.
Are there two systems here?
No.
There's two what?
Inequalities.
So what did it make true? Both.
Inequalities.
There we go, right? That's the language. Right? So it made both inequalities true. But how did I know that it made both inequalities true? I didn't just like magically pull it out of my booty. Like I had to know, I had to prove it.
You plugged it in.
Let's work on that language. Not plugged it in.
Substituted.
Substituted, right? We want to be careful with our language. Make sure we're paying attention to that. Meaning I substituted 3 in for x and 1 in for. And when you check these two inequalities, that point makes both of those inequalities
Equivalent. Equal.
True.
true. Equivalent, remember, means that they're effectively the same, but they look different. They're not equivalent, but it does make both inequalities true. We go with those major ideas. And that was building up to this last question. That was probably the most difficult one on here. But something we've studied before. Create a graph to identify all solutions for the system given. What's the first thing I need to do for that system? What was the first thing I did here?
Find your slope and your y-intercept.
Of the what? Of the boundary line, right? When I was writing the inequality, I was looking for the boundary line. When I'm graphing, what am I going to look for? So what's the first big picture note that we need to make? Graph the boundary line, right? Now there's lots of different ways to graph that boundary line, and so we're not going to go into those details, but the first thing that you need to do is you got to graph the boundary line. We're going to be shading a half plane, but to know where we stop, we got to have the boundary line. And we may have made mistakes on this, and that's okay. But hopefully you did at least one of them correctly, then you just need to ask questions about the other. Right? And Layla, just because I know I saw this for you, right? Now I will point this out. What form of a line is that inequality in? Standard, right? So what was the most common method we looked at for when it's in standard form? X and Y intercepts. That's personally what I would do when it's in standard form. You don't have to. Layla, I saw attempted converting it to slope intercept, which you started this out great. Because what is 3x minus 3x?
0.
But then what do I need to divide by to isolate y?
4.
No, sir.
-4.
And I divide by -4. Remember, we need -4 divided by -4 because that creates a. And what do I need to do with my inequality?
Divide. We're talking about.
So it's still this?
I got it divided.
So that's what it should be?
Yeah.
Say again? Say it louder.
Put
Well, but notice what's a negative divided by a negative?
Positive.
Positive. A positive divided by a negative is
Negative.
negative. Still made a mistake though. Language.
Reverse the direction.
There we go. Remember, I divided by a negative, so what has to happen to the inequality here? You gotta reverse that direction.
I forgot about that.
Yep. See, again, this is why we do review, because if we don't ever practice this later, we forget a lot, don't we?
Yep.
Here's something I want y'all to hear me very clearly on. Learning takes time. You cannot expect yourself to perfectly understand this if we study it once during a unit and just move on. You gotta have a little bit of review. So I'm building that into this fourth quarter.
Last 9 weeks, I'm so happy.
I know, I'm ready for you to get out of here too, Corell.
I'm ready to come back.
Just kidding.
I got you.
I'll miss Corell next year, saying all his goofy stuff.
Will you?
I mean, who am I going to be able to rag on about how swole he is and how big he is?
So yeah, dude.
How many his 8-pack and his huge amount of push-ups?
There might be a
You
freshman
know I
this
got an
year.
8-pack now. Don't do that.
I don't know that.
Everybody
You
know
did
that.
42 push-ups.
Okay.
You're gonna have to do some extensive
All right.
activity though.
So notice I graphed the boundary line. When it was in slope intercept, I just did the slope and y-intercept.
What's the slope of that
Yeah,
one?
don't choose a ratio.
What? I just showed how I converted to slope intercept, but I would just do x and y-intercept with that standard formula.
I'll try it down, Miss King.
Okay?
Up 3,
Yeah.
1, 2.
Yeah, it's 3 to 1, so up 3 to the right 1.
No, for the other one.
Oh, up 3 to the right 4?
Oh, yeah.
But again,
What?
I would just use x-intercepts and y-intercepts.
That one is not right. Look at the second one. The y-intercept is -2, up 3. That'd be +1.
Hey look, I hit that point.
Then what's the other point?
Notice I used the x-intercept.
Mm-mm-mm.
8/3, 0.
Oh, okay.
Is that, so like, notice that, and that's the difference, right, between slope intercept and using those x and y intercepts. But it does give me the same line, right, so I just used a straight edge to get those points well. But good catch. Good catch on noticing it wasn't up 3 to the right 4. So after I graphed the boundary line, what did I have to do?
I don't even know.
I had to shade, right? So I had to shade. Shade what? When we shade these inequalities, what are we trying to shade?
Half there.
A half plane. So which half plane do we shade though?
The inequality.
Quadrant 3.
Inequalities.
What should this point do?
Make it true.
So what am I shading?
The
Shade half
solution.
there.
Shade the half plane with
The
solutions
solution.
Still my stuff.
of the inequalities, right?
Yeah, something like that.
So notice we're just going to do that for each inequality. And then to finish it up, right, how did I know to shade right here?
Because it makes it true.
That's what, Desiree?
Oh, we said half.
All of the
Makes all the inequalities, or in this case 2, so both of them true, right?
Miss Kim,
Sir,
you forgot to ask something.
what?
You forgot how do you check? You forgot to ask how do you check?
Good job, right? So, yeah, I meant to talk about that. So when we look at that solutions, that's a great job. So how did I know that that point, or how could I show that that point is a solution?
Substitute in my fault. I almost said plug in.
Right? So great idea. Correct terminology is substitute, right? So I can substitute that point in. That's -3, 1. So 3 times -3 minus 4 times 1 is less than 8. Well, that's a pretty negative number. Is that less than 8? So am I shading the correct region?
Yes.
That's the solution, right? So good catch on that, Corell. So ID region with solutions for both inequalities, right? Please note, like I'm going over this. This is what's important, right? Like this is the solution for this one particular problem, but this is the overarching idea that drives everything else. That's the most important part. Alright, so that I don't put Peyton further to sleep, I will leave this up here so that if you need to copy it down so that you have notes on it, cool. But let's start looking at today's agenda and the objectives. So you should have 6.5, the tortoise and the hare out. Because I handed that out at the beginning of class.
I don't know that.
We did not.
Hare.
Alright, so objectives, right? Remember, it's hard to know what you're, or figure out if you've learned what you're supposed to learn unless you pay attention to the objectives. So, first things first, we have our first standard for mathematical practice. We're going to use appropriate tools strategically. It's math. What tools am I talking about? I'm not looking at a hammer or a screwdriver. What tools am I talking about for mathematics? Desmos, is that a tool that we use?
No, it's a lame.
You're a lame tool. Just kidding. A calculator, right? That's what Desmos is, a graphing calculator. What else?
Pictorial.
Say it again. Okay, we can use Khan Academy to help us learn things.
Graphing.
Pictorial representations, graphical representations.
I forgot.
Tables,
Yeah.
right? Tabular representations. Algebraic, our equations, our inequalities. What else?
Words.
Our verbal representations, right? So don't forget, right? We have Desmos to help us get some of those representations, but the mathematical representations help us make sense of what we're studying. All right, we want to attend to precision to do these two objectives. Corel, can you read our first objective?
I got a question. What does it end? Does it end at and?
Yes.
Contrast exponential and quadratic functions and.
Someone else will do the second part.
That's a,
I will do these things to contrast exponential and quadratic functions, and then we're going to do this.
I got you. My fault.
There you go. No, I get why it's confusing. That's why I did that. So we haven't talked about exponential too much this unit. Well, what have we focused on so far? Quadratic and one other. And linear, right? We talked about those two comparison a lot, right? We're going to introduce exponential as well this time to do this really important final thing. Layla, can you read our second objective? Now what is differentiate? Differentiate. Yeah.
The rates of change for exponential and quadratic functions.
I would imagine there's at least one word we need to talk about. What word in the objectives do we need to discuss? Differentiate, right? Look at the first half of it though. Difference. When you differentiate, you just tell the difference between things. Right? So we're going to tell the difference between the rates of change for exponential and quadratic functions. So as a quick reminder, a linear function has what rate of change? Not just additive. Constant additive. What's a quadratic have? Linear additive. Yes, ma'am. Man. Linear additive. What does an exponential have?
My booty's just too big.
Not just multiplicative. Constant multiplicative, right? So we need to always keep that in mind that we're looking at these different rates of change, and we're going to look at a little bit more within that tomorrow. Okay.
Miss, can I have a question?
No, sir, I don't have an answer.
Is constant multiplicative and constant rate of change same thing?
So a constant multiplicative is a type of constant rate of change. When you hear other teachers talk about a constant rate of change, they're usually just talking about a constant additive. But like when we talk about an exponential, we are constantly multiplying by the same thing every time, right?
Yes, sir.
So I note that difference in the exponential and the linear. Okay, so we're looking at the tortoise and the hare, and I assume most of us have heard the story of the tortoise and the hare at some point in our life, yeah?
No.
All right, well, let's recap it for Corel, because he has never heard the tortoise and the hare. Who can tell us what happens?
A rabbit and a turtle were racing, and the rabbit
Oh,
got so
yeah,
far
yeah,
ahead,
yeah, yeah.
and he's like, I'm taking out, and the tortoise beat him.
Right? So that tortoise, or the hare got really cocky. He's like, hey, I'm winning this race by a lot, so I'm just going to, take a nap. I'm going to relax. I'm going to enjoy life. And then the tortoise caught up. It's a really good story of a very simple principle of hard work pays off. I feel like you've heard me say that before. You got to constantly put in the effort and the work, right? So the hare was mocking the tortoise for being slow, and the tortoise replies, slow and steady wins the race. The hare says, all right, we'll see about that. And then challenges the tortoise to a race. The distance from the starting line of the hare is given by this function, right? So what do we mean by D? Distance.
Distance.
In what?
Time. I'm guessing.
In.
Time.
Not distance and time.
I thought it was time, I'm just guessing.
I think what is Corell probably talking about when he says time?
The T.
The t, you're not listening to what I'm asking though. The distance is being measured in what?
Meters.
Meters. The time in
Seconds.
seconds, okay? So that's a huge thing to notice here, right? And which equation are we referring, or who is being modeled by this equation?
The rabbit and tortoise.
Which one is t squared?
The tortoise.
Where are you getting that information from?
I just know.
You just know?
Yeah.
Now how about you read the sentence right ahead of this, Corell?
Which one?
The one that's underlined.
This from the starting line and the hair is given by the function.
So who are we talking about?
Hard hair, hair, hard, he, I don't know.
What are you saying?
Hard hair, he, hard, he. Yeah.
Horn his
Never
hood.
heard of the term hare. It's a rabbit.
Hard, he, hair. I don't know.
Well, I've said it multiple times, so if you were listening,
Oh, I said hard, he, hair.
no. So
the
d equals t squared. Who's that talking about?
hard hair.
The hare. Thank you.
You're welcome.
What kind of name is that? You
It's
said it's
literally what? It's a rabbit, dude.
rabbit. I don't call it rabbit. I call them rabbits. Rabbits.
Cool story, bro. So because the hare is so confident that he can beat the tortoise, he gives the tortoise a 1 meter head start. The distance from the starting line of the tortoise, including the head start, is given by the function d is equal to 2 raised to the t. So who is this equation describing? Or whose distance is this equation describing?
The faster one. Right. I mean the
Tortoise.
tortoise.
Okay, we already have the hare, so this is the tortoise.
My bad, my bad.
And you don't know that the tortoise is faster.
Yeah, it's got that nice speed.
I made the other one.
We're going to talk about it. Okay, one thing, and I will say this, we're going to get to this number 5 tomorrow, so I'm not even going to worry about it right now. One thing, because this came up earlier in class, and this is important to recognize, we need to know or be able to think through which of these is x and which one is y, because we don't have a d-axis and a t-axis, we have an x-axis and a y-axis. So I want you to take 60 seconds, talk with your group, and I want you to figure out or try to determine what do you think is x, your d or your t, and then based on that, which one is your y.
You said it's weird. Oh, it's not the distance and time.
Yes.
And for hair and tortoise.
Nope, just distance and time. Which one's going to be independent, which one's dependent, which one's x, which one's y. So what are y'all thinking?
T.
Time. Yeah.
It's right.
Which one?
Distance is one.
Distance is y, t is
Distance
time.
yeah.
Make sure you're able to explain why you think that, because I'm going to ask you to justify it.
Oh, that's fine.
What are you thinking?
Didn't explain it.
This distance is y. The T is time.
Good job. T is time, but if distance is y, you're saying t is
Time. What did I just say? What did I just say?
time, but you said distance is y, so time would be,
Oh, X.
thank you, so why are you thinking
I
that?
was about to say T again when you said that. I don't know why.
So why are you thinking that?
Because I'm thinking about the T for time. I don't know why. Like, I said that already.
Mm-hmm.
I was thinking the first initial.
Do y'all agree with him?
Yeah, they agree with me. They all
What?
agree with me. In my group.
It sounds like you just saying stuff and
Yeah.
y'all don't come to a consensus.
They agree with me. I explained to them why too.
Alright, Corell, then explain to us. Why is time my x and why is distance my y?
My chest hurt. I can't breathe right now.
Are you having a heart attack?
Yeah, Shelby got that for me.
Which arm is
No
right?
notes. I
Oh,
would take notes.
That's not a heart attack. Yes, sir.
Okay, so in science they do this thing it's called dry mix time, and it's the independent variable is going to be on the y, right? So the independent variable on this would be distance. And
Like
the
that.
dependent variable is going to be the time, so it's going on that.
So y'all agree that the independent variable is on the y-axis?
Oh wait, no. No, the independent's on the x. Sorry.
You're talking about, because you're talking about dry mix to help
Yeah.
you, yeah. So the dependent or response variable is our y. I
Wait,
think
dry
that's
mix.
what
What does that mean?
What?
isn't that what that comes
Yeah, it's a thing in science.
from? It's a thing some science teachers teach.
Dry mix.
Dry mix, dependent
What
or
the-
response variable
What's what?
is y.
Oh.
The manipulated or independent variable is
It's
x.
X. Oh, Oh, I don't understand that, but it sounds cool. That
You
makes-
only have a mark?
You don't have to worry about it, okay? So, you're confident that time is independent? Is that what you're saying?
Yes, because it keeps going.
Right, time keeps going. There's another language, what were y'all saying? You know, we were talking about something else, weren't you?
Another language?
We were just saying that time is always in the x-axis.
Time is always an x-axis.
Yeah,
Okay, so
I
yeah,
see it, I
we
see
need to
that.
make sure that we note, hey, this is equivalent to x, my independent variable. Right? And notice the distance depends upon the time. One thing I would also point out is, doesn't this look like y equals 2 raised to the x? So
Yes,
d is y, t is x?
yes.
It's quadratic?
Sure. Not telling you that answer. Y'all have to talk about it within
It is
the
quite
problem to think through some things. Last detail I do want to point out is this.
Well, you put tortoise right there or no?
That's a blessing.
What's the question?
What time does this race start at? So like as soon as the gun goes off, what's the time?
1 meter.
What?
1 meter.
0 what?
0.
0 what?
Seconds.
Seconds, thank you. So notice, right, if I'm thinking about that, what is 0 squared?
0.
Right, so 0 seconds in, what's the distance of the hare?
0.
0 meters, that makes sense. But if you look at the tortoise,
1 meter.
2 to the 0 is
1.
1, right? Because how far did the tortoise start ahead?
1 meter.
1 meter ahead. We all good with that idea?
Yep.
So consider those ideas. I want y'all to take 60 seconds, no, 45 seconds, think on your own how we're going to approach this problem. And then after that 45 seconds, you're going to talk with your group to figure out how you, as a group, want to tackle this. So 45 seconds, think about what tools you want to use